Hi there, so we're using the 4th edition of the Physical Geography book by Oxford University Press, and we're going to be on Unit 5, Radiation and the Heat Balance of Planet Earth. The objectives of this unit are to understand the processes by which heat flows within the Earth system, follow the cascade of solar energy to Earth's surface and resulting energy exchanges between surface and atmosphere, link the greenhouse effect or Earth's habitability, understand latitudinal differences in net radiation, and explore global energetics. Alright, so let's get started. So here are some notes at the beginning of Unit 5 that you want to know. As the temperature of an object increases, its internal energy increases. All objects lose heat through radiation. Radiation doesn't require a transfer medium, and the amount and wavelength of radiation depends on temperature. So then we go into conduction, which is energy transfer through contact. And an example of this is day and night. And as the heat warms the surface during the day, that warm temperature flows to the cold underneath the surface. And then that slowly, heats up a little bit more. And at night, when the surface is cold, the warmer temperature from the daytime flows up. And the same happens on a bigger scale from summer to winter. So the surfaces are less cold during winter. Alright, and then we have convection, which is through flow of air or water. Heat is transported from one place to another. Here, let's zoom out a little bit. So that's convection. And then there's two types of convection that they go into detail, and these are the two. Sensible heat, when air or water goes from a place with one temperature to a place with a different temperature. And then latent heat, when heat transfers with water vapor. Alright, so some more notes are solar constant. The intensity of sunlight at 1,364 watts per meter squared. This is, through diffusion and things, reduced to 341 watts per meter squared, as shown due to the planet being only half in sunlight and the curvature of planet Earth. And then direct radiation is 30% of the heat coming in. Diffuse radiation is scattered through the atmosphere and is 20%. 25% is absorbed by the atmosphere and 25% is reflected away. And albedo, is the proportion of incoming radiation that's reflected by a surface. Atmospheric emission depends largely on its temperature. Counter radiation is the atmosphere emission, 2 times the heat to the surface as the sun. Net radiation is the difference between absorbed and emitted radiation. And the greenhouse effect. Because the effective emission altitude is raised to a higher and colder place, temperatures must rise to reestablish equilibrium between emitted and absorbed radiation. We're going to briefly look at clouds and gases and greenhouse effects. And clouds absorb a wide range of wavelengths and transmit no terrestrial radiation. However, the greenhouse gases are more selective. They will not absorb wavelengths from 8.5 to 13 micrometers. This is called the atmospheric window. As we add greenhouse gases to our atmosphere, we narrow the window and increase absorption. And because these are naturally found in small amounts, our additions mean a large change and impact on the environment. The key terms we covered in this unit were albedo, conduction, convection, counter radiation, diffuse radiation, direct radiation, greenhouse effect, latent heat, long-wave radiation, which is terrestrial or Earth-related, net radiation, regular radiation, sensible heat flow, shortwave radiation, which is typically solar, terrestrial radiation, and thermal energy. And thermal energy just being heat. So we generally covered those. And some of the review questions that the book gives are: explain the 3 modes of heat transfer and how they differ. And those 3 modes of heat transfer we covered earlier, and those are conduction, convection, and radiation. And then it says what is latent heat transfer, and that was through water vapor. What are the differences between solar and terrestrial radiation? Solar is shortwave, terrestrial is longwave, etc. How much of the solar energy entering the atmosphere is absorbed by the atmosphere, and how much by Earth's surface? How much is reflected by the atmosphere and by the surface? And we covered that. Describing your own words the meaning of the term greenhouse effect. We went over the greenhouse effect. And what is meant by the term albedo. Give some examples of its application in your daily life. And so we gave the general definition, and other applications would be black surface top and its absorption of it, while white surfaces like snow are more reflective. And you can go through the book and find more examples or Google it. So that is Unit 5.